Hello students, and welcome to the first lesson of algebra. Now, each time you enter one of these videos, you will see an entry task as you enter the video. And this entry task, I want you to think about this. Which of the following, A, B, C, D, E, which of those are equations? If they aren't equations, what are they? So I'd like you to pause the video and think about that, then unpause it, and we shall discuss. So, when I see the word equation, and I've underlined it because when I think of the word equation, I think of the word equal. Equation, equal. So, if we have an equation, we must have an equal sign. If you don't have an equal sign, well then you don't have an equation. So, this is not an equation because there's no equal sign there. I have 3 minus 4x. That's it. So that is not an equation. Here, look at that. I have an equal sign. So yes, this is an equation. Equal sign. Yes, it is an equation. And here, no equal sign. So this is not an equation. And here, another equal sign. So yes, this is an equation. Things like this, things that are not equations, that do not have equal signs, we call these expressions. Expressions. Anything without an equal sign, you could call it an expression. So, now that we're done with our entry task, let's move on to what we're going to talk about in this lesson. So, this is Chapter 1, Lesson 1, 1.1, first section of Chapter 1. It is about solving simple equations. Our learning target is that you know what linear equations are. What is a linear equation? The success criteria, how do you know if you know what a linear equation is? Well, you will be able to solve one-step linear equations using addition, subtraction, multiplication, and division. Now, you might not know what that means right now, but as we go through the lesson, be checking yourself. Can you do this? Can you solve one-step linear equations using these? Do you know what a linear equation is? If you don't know that by the end of the lesson, you might want to talk to your teacher or rewatch this video. So before we solve linear equations, we need some vocab. So the first vocab word we're going to talk about is linear equation in one variable. The definition of a linear equation in one variable is an equation that can be written in this form where a and b are constants. That means that they are numbers. So a and b are numbers. And a cannot be 0. So basically you have to have an x in it. There needs to be a variable and just one variable. So I can't have 3x plus 4y equals 0, then that would be 2 variables, not 1 variable. The letters, when we talk about a variable, we're talking about letters. So x, y, z, p, heck, you could even use a smiley face if you want to, but a variable is something that we don't know the value of. So 3, I know 3 is 3, but I don't know what x stands for. Its value can vary. Variable, that's where the name comes from. Okay. So an example, some examples of a linear equation in one variable are these. And then I include the Spanish version in case you want that or need that. So I recommend that you write these things down. If you're in my class, you have to write them down. You are required to write them down because it's important. We're going to solve linear equations in one variable, so you need to know what they are before you're going to try to solve them. So you can pause the video, take a note of that, unpause it, and let's keep scrolling. One more vocab word before we get into the rest of the lesson. Inverse operation. Now, when you hear the word inverse, I want you to think opposite. Inverse operations undo each other. So inverse operations, the definition is two operations that undo each other, such as addition and subtraction. For example, if I give you $5, you have plus $5 than what you have right now. But if I take away your $5, well, you had the same money as when you started with. I undid it. I gave you $5 and I took away $5. I added $5 and then I subtracted $5. So inverse operations undo each other, just like addition and subtraction. Addition and subtraction is one example. Multiplication and division are also examples. If I multiply by 5 and then I divide by 5, I have the same thing as when I started. And then, of course, the Spanish, should you need it. All right, pause that, write it down if you need to, or pause it if you need to, and we're going to keep scrolling. Okay, important information before we begin. We have the addition and subtraction properties of equality. Now, let's get a different color in here. Addition property of equality, subtraction property of equality. So, they give you this property in words and in algebra. So, right, we can think of algebra as a language. We can think of math as its own language. So we're going to put this in words, and then we're going to show you what that looks like in math speak. So let's focus on just the addition property of equality first. So in words, adding the same number to each side of an equation produces an equivalent equation. What does that mean? Well, let's think of it this way. 2 equals 2. Do you agree? Is 2 equal to 2? Well, yeah. 2 is the same thing as 2. Those are equal. So watch this. If I add the same number to each side of an equation, I should get an equivalent equation, or the same equation, an equation that is still true. So if I add 3 to both sides, I have 2 plus 3 is 5, and 2 plus 3 is 5. So I get 5 equals 5. Is that still true? Yes. Yes, it is. 5 is the same thing as 5. So if I add the same thing to both sides of the equation, you're still going to have basically the same equation. Okay, so in algebra, that looks like if A equals B, if 2 equals 2, or if A equals B, if I add C to both sides, A plus C, B plus C, this equation and this equation are the same thing. We go from 2 equals 2 to 5 equals 5. Still the same. The subtraction property of equality, let's change colors now. The subtraction property of equality says the same thing, except now we're talking about subtracting. So if I have 9 equals 9, and I subtract 2 from both sides, there we go, you can see it now, and I subtract 2 from both sides, now I have 7 equals 7. Same thing. 7 does equal 7, 9 does equal 9, same thing. So, key takeaway is these words right here. Adding the same number or subtracting the same number from each side of the equation produces an equivalent equation, or an equation that's basically the same. So we can add to both sides, and we can subtract to both sides, and it's all Gucci. Now let's move on to an example. Great, we heard about this property of equality. Sounds so wonderful. What do I do with it? Why does it matter? Well, say we're looking at this equation, for example. A, x minus 3 equals negative 5. I want to know what can x be in order to make this statement true? What number minus 3 gives me negative 5? Now, you might be able to figure it out in your head. You might be able to say, oh, I know this minus 3, that's negative 5. Like if I told you 9 minus x equals 7, 9 minus what equals 7? Well, 2. X would need to be equal to 2. And you're totally right. That's one way to solve it. That is exactly okay. That is perfectly okay. That is one way to solve this type of equation. But what happens when they get to be a little more complicated? What about this? Do you know that one in your head? I'm a math teacher and I don't know that one in my head. So this is why we kind of teach you the process. You know what this says. This equation says I need to find a number that if I take 9 minus that number, I get 7. That's the most important part that you know. Now we're going to show you a process to make these equations easier. If you can't figure it out in your head, well, you can do this process to help you along. So, we're trying to figure out what number minus 3 equals negative 5. Well, remember from the last slide that I can subtract or add the same thing to both sides and I'll get an equivalent expression. So, I have x minus 3. I want to get x by itself. In the end, I want x equals something. So in order to get x by itself, I have to move this negative 3 away from the x. How am I going to move it away? Well, I can do the opposite, or the inverse operation of negative 3 by adding 3. It's like I took $3 away from you, but now I gave you $3. They cancel each other out. It's like I did nothing. So, in order to get rid of negative 3, I'm going to do the opposite of subtraction, which is adding. I'm going to add 3. And remember that these properties said we had to do it to each side. We have to do it to both sides of the equation. So if I add 3 over here, I have to add 3 on the other side of this equal sign. The other side of the equal. I like to think of equations as teeter-totters. You know those toys on the playground where one kid sits on this side, one kid sits on this side, and you go up and down. You sit, yeah, I'm an artist. But yeah, you go up and down like that. So you want to keep your equations perfectly balanced. Perfectly balanced. You don't want one side up, you don't want the other side up, you want it perfectly balanced. So whatever you do to this side of the equation, you have to do to that side of the equation. Otherwise, your equation is all unbalanced, and the universe is unbalanced, and you wouldn't want that. So, if I add it to one side, I've got to add it to the other. And now, here, I'll even draw a line down that equal sign so we know add 3 to this side and to this side. So that line will help us see our different sides of the equation. And now, minus 3 plus 3, those undo each other. They're gone. So now I just have x on this side equals, well, what is negative 5 plus 3? Let's see, that's like 5 minus 3, which is 2, but I need a negative. Negative 2. You can also do that with your calculator. There is no shame in that. But look at that. Now I know x is equal to negative 2. And we did exactly what we wanted to. We wanted to get x by itself, and we wanted to know what number could we make x that would make this equation true. Now there's one more thing you want to do. You're like, oh great, I found x, cool, I'm done. But wait a minute, are you positive that that x is correct? Are you positive? Now you might be, but I want to show you a way that you can check to make sure that your answer is indeed absolutely correct. So I'm going to take the original equation, x minus 3 equals negative 5. And if I take negative 2, and I put it in where the x is supposed to go, I better get the same thing. I better get the same thing on both sides of the equation. So I'm going to say negative 2 minus 3 equals negative 5. Is this true? Well, negative 2 minus 3 is negative 5. Is -5 equal to -5? Yes, it is. We were correct. Wonderful. Okay, I know that's a lot to take in. First problem we've done in algebra, so let's do another one to make sure we know what's going on. Get a different color in here too. 0.9 equals y plus 2.8. Okay, so I want to figure out what number plus 2.8 will give me 0.9. Now, you could think about it really hard in your head, or we can do this process that we came up with over here. I want to get y all by itself, which means I need to get rid of this 2.8. So, instead of adding 2.8, I'm going to do the opposite of add, which is minus, subtract. I'm going to subtract 2.8. And oh, my teeter-totter's unbalanced. Remember, if I do it to one side, I've gotta do it to the other. So we also need to subtract 2.8 over here on this side of the equal sign. So now these go away. Plus 2.8 minus 2.8, it just goes away. And now I have y equals 0.9 minus 2.8 is negative 1.9. And look at that, y is by itself. So we have solved the problem. We have y equals negative 1.9. Now, are you positive? Are you positive about that answer? Well, let's check just to make sure. Let's take the original equation. 0.9 equals y plus 2.8. We're going to take this y and shove it back in there and see if we get the same thing. 0.9 equals negative 1.9 plus 2.8. Negative 1.9 plus 2.8. And we get 0.9 equals 0.9. Look at that! The same thing. That is indeed true. 0.9 is equal to 0.9. Wonderful. Okay, cool. Now you know how to solve equations by adding or subtracting. Let's make sure that we were right, though. Look at that. That's what we got, and that's what we got. Cool. Cool. All right, next. We said in our success criteria that you should be able to solve using addition, subtraction, or multiplication and division. So now it's time to talk about multiplication and division. Remember that multiplication and division are inverse operations. That means that they undo each other. So again, we have our words and we have our algebra. So the multiplication property of equality tells us multiplying each side of an equation by the same non-zero number, that just means that your number cannot be zero, non-zero, not zero, produces an equivalent equation. So if I have 2 equals 2, and I multiply both sides by 5, I get 10 equals 10. And that is true. Both of those equations are true. Why can't it be 0, you ask? Well, what if I have 3 equals 5? That's not true, right? 3 is not equal to 5. But if I multiply by 0 on both sides, I get 0 equals 0. Well, that's true, right? But just because this is true does not mean that this is true. So that's why it has to be a non-zero number. Okay. So if A equals B, then A times C equals B times C, as long as C is not 0. Different color. Division property of equality states that dividing each side of an equation by the same non-zero number produces an equivalent equation. So if I have 8 equals 8, and I divide both sides by 2, I get 4 equals 4. And both of those are true statements. Now, the reason that this cannot be 0 is if I try to divide by 0, the world will explode. You cannot divide by 0. You absolutely cannot do that. You never, never, ever divide by 0. Don't do it. Okay, so wonderful. Just like our addition and subtraction properties of equality, we can multiply or divide the same number on both sides of the equation, and we have an equivalent equation. Now, I know what you're thinking. Mrs. Dodge, this is great. I don't know what it means. I don't know how to use it. That's okay. Let's see an example right now. Solving equations by multiplying or dividing. Let's look at the first one first. Here we have negative n divided by 5 equals negative 3. Now remember, the end goal, when we are trying to solve an equation, we are trying to get n all by itself. We want to isolate him, get him by itself. So, what's going to get n by itself in this case? Well, here, if I look right here, I have n divided by 5, and negative 5. We can put this negative down there, and it's the same thing. So I have n divided by negative 5. What's the opposite of dividing? Multiplying. So let's multiply by negative 5 on both sides, because remember, if I do it to one side, gotta do it to the other. So I'm going to multiply by negative 5 on this side too. This goes away. Multiply and divide goes away, undoes each other. So now I have n equals negative 3 times negative 5. The negative and the negative make a positive, always. That's how I think about it. Two negatives, they come together, and they become a positive. Two unhappy people come together and they become happy because they have each other, is how I think about it. So negative, negative make a positive. 3 times 5 is 15. So this is positive 15. Again, remember, there's no shame in using your calculator. Wonderful. We got the n by itself. So we are done, except we need to check. We need to check and make sure that we are correct. So if I take the negative n over 5 equals negative 3, and I put the 15 in there, I get negative 15 divided by 5 equals negative 3. 15 divided by 5 is 3, and it's negative, so I have negative 3 equals negative 3. Boom. Boom. We were right. Wonderful. New color. New question. Here we have, whoa, what is that symbol? Let me draw it bigger for you. This is the symbol pi. You'll learn more about pi in geometry, but maybe you've heard of it. It's just a number. 3.14159. Don't quote me on those last ones, I'm not sure. But pi is just a number. Pi is a Greek letter that we assign this number to. So when you see pi, don't freak out. It's just a number. It's kind of like 3, but it's not. It goes on forever. But it's just a number. So when you see it here, when you see, oh, I need to get this x by itself, but there's a pi attached to it. Well, that's okay. I have pi times x. That's what it means when a number and a variable are touching each other like that, when they're right next to each other, it means multiply. This is the same thing as 3 times x. So because the pi and the x are right next to each other, I know that that means multiply. What's the opposite of multiplying? Dividing. So if I divide by pi, these will go away. Multiply by pi, divide by pi, just undoes each other. So I'm going to divide both sides by pi, and it'll go away on this side. Now I have x equals, do not lose your equal sign, always keep your equals. X equals let's see, negative 2 pi divided by pi. Oh, well, hey, pi divided by pi, that's just 1. It's like if I have 5/5, that's equal to 1. Anything divided by itself, 3 divided by 3, 2 divided by 2, it's all equal to 1. So this is just 1, and negative 2 times 1 is negative 2. Now, how can we be sure? Oh, we need to check our answer. So let's take the original equation, pi times x equals negative 2 pi. Let's put negative 2 in there and see if we're right. Pi times negative 2 equals negative 2 times pi. Well, yes, that's exactly correct. Just because the pi comes before the negative 2, remember 3 times 4 is the exact same thing as 4 times 3. So pi times negative 2, that's the exact same thing as negative 2 times pi. I can switch them around and it does not matter. So this is the same thing as negative 2 times pi, which is totally equal to negative 2 times pi. There we go. And it's actually not too bad to see. If I look at this equation right here, I have a pi here and a pi here. I just need to know what x is. Well, the number over here with the pi is negative 2. So shouldn't this x need to be negative 2? Yes. Yes, it does. And if that didn't make sense, don't worry about it. Okay, new color. Last question. 1.3 times z, remember, because they're touching each other, because the 1.3 is right next to the z, it means they're multiplied. So 1.3 times z equals 5.2. Now remember, I want to get the z by itself, so to undo multiplication, 1.3 times z, I need to divide by 1.3. That'll make them go away. Oh, but wait, if I do it to one side, if I divide by 1.3 on one side, I have to divide by 1.3 on the other side. So I'll divide by 1.3 over here as well. Now these are gone, so I just have z. But what is 5.2 divided by 1.3? 5.2 divided by 1.3 is 4. I really thought we were going to get a decimal there, but that's all right. So z equals 4. Are we certain about that? I don't know. We better check our answer. 1.3 times z equals 5.2. Let's shove that 4 in there. 1.3 times 4 equals 5.2. Does it? 1.3 times 4 is 5.2. 5.2 equals 5.2, so yes, z equals 4. Let's see if we got it right. N equals 15, x equals negative 2, and z equals 4. Boom. We are good. Alrighty. That is all the material I have for you today. So, questions. If this were my class, this is the time that I would stop to ask for questions. Questions about one of the examples we did, questions about the addition property of equality, something like that. Questions are amazing. If nobody has told you that in your life, maybe you had a teacher in the past that was like, you should know that, don't ask me this question. No, don't listen to that teacher. Questions are good. If you are struggling, if you're trying really hard but you can't quite get it, that is a good thing. It means that your brain is growing. It means that you're learning. So there is absolutely no shame in struggling to understand something. I have struggled so much in learning math. So much. Yeah. So if it's bad to struggle in math, then your math teacher is bad. But I'm not. It's good to struggle. It's good to try hard to understand something. And it makes it all the more rewarding when you finally understand it. So if you have questions, please ask them. If you're scared to ask your teacher, you can always email me. You can always ask me. I love questions. So, yeah, ask questions if you have them. Now, if this were my class, I would assign some practice problems. This is a lot of problems. This might not be the homework that your teacher gives you. That's okay. These are practice problems. So if you wanted to practice everything we just did up here, you could do that by doing these problems. So if you want to pause the video and look at this screen and do all of the problems, go for it. If you're like, holy cow, that's a lot of questions. My teacher didn't assign that many. You don't have to do all of them. But these are great for practice. All right, and lastly, this is something I do for all of my classes. It's a launch. Launch you off to the rest of your day. Launch you off being done with math class, or at least being done with this video. So, the first launch I have for you is a quote that I really like. Don't seek to control others. Seek to gain greater self-control. Master yourself. I spent a lot of time when I was in high school or when I was younger trying to control others, make them like me, make them ask me to hang out with them, and it's really exhausting. And I come to find out you can't control other people. You can't make other people like you. So instead of trying to control other people and make them like you and make them do things with you or something like that, seek to have greater self-control. Seek to be able to, instead of going, I want them to like me, ask, why do I need them to like me so badly? I'm a peach. Some people don't like peaches. That's okay. Not everybody has to like me. So if you can master yourself, you won't need to try to control people as much. So that is my launch for you today. Some words of wisdom. Take them with you as you go throughout your day. Have a wonderful rest of your day, and thanks for watching. Bye.